Welcome to Brain Vision.
Okay, so in this question we have an aluminum rod, uh, and it's clamped 1/4 of the way along its length. It's attached to a variable frequency output, um, and so it can provide any frequency that we need. Um, but the lowest frequency that produces a resonance in this rod is 4,400 hertz. So our F is going to be 4,400 hertz. And then we're also told that the speed of sound in aluminum is 5,100 meters per second. And so we're asked to figure out what the length of the rod is. So what we need to figure out here is what is the standing wave pattern. So the lowest frequency is going to have the fewest number of nodes possible. It's going to be essentially our fundamental. But we do need to notice that the rod is clamped 1/4 of the way through. So if we set up like a little standing wave diagram, I'll put dotted lines that are supposed to represent the different quarters, dividing it evenly into 4 parts. So if we say that it's clamped here on the left fourth, the left side 1/4 away from the end, that means that we have to have a node right there. We also should have antinodes at both ends because the ends are not restricted in any way, so they should be free to vibrate. So the only conditions that we have are that the ends of the rod have antinodes, and then this point has a node. Well, for this to happen, we should go from an antinode to the node in 1/4 of the length, to another antinode in 1/4 of the length, back to a node in 1/4 of the length, and then to another antinode at the other end. And then if we mirror that to give our standing wave pattern, we get this shape. So if we look at this and compare it to the wavelength, we see that we go from, at the left side, an antinode to its opposite antinode in the middle, and then back to the original antinode at the right side. So that tells us that the wavelength of the rod, or the wavelength of the wave, is equal to the length of the rod. So we can say then that the wavelength is going to be the speed of the wave divided by the frequency. And we know that this is the setup because we can't have any fewer nodes in the rod than we already have in this setup. We'd have to have another node in the left quarter of the rod in order to set up any other standing wave that would fit these conditions. So we know that this is going to produce the frequency of 4,400 hertz. So that's why we can go ahead and go with this. So we can say that the lambda, the wavelength, is equal to v divided by f, which then we can just replace lambda with L, which is what we're trying to solve for. So L is equal to v divided by f. Scroll down a little bit. So L is going to be equal to 5,100 divided by 4,400. If you calculate that out, you should get that the length of the rod is 1.16 meters. And that's our answer.